So we're going to talk about all different kinds of bar graphs, line graphs, all different kinds of data over the course of the next unit. And we're going to start with some simpler ones. And we're going to start with how to interpret those. So when I say interpret, what does that mean? Like if I say, can you interpret this for me, what does that mean? I mean to interpret something.
Translate it?
Yeah, kind of translate it. Okay, because if I just look at that picture, you guys might be able to tell me what that means. But if like a fourth grader said, if a fourth grader got that graph, would they be able to tell you exactly what that graph is telling you? Maybe not. So if I'm looking at that bar graph up there, what are some things you notice? What can you interpret from that bar graph? What's it about? What's it recording?
Well, you know, so the bar graph is title.
Okay, and what's the title here?
Fat content of a sub-sandwich.
Yeah, so the fat content in a sub sandwich. So what can you tell me about this sub sandwich? Do you know what's on it?
On the y-axis is.
Yeah, you can tell what's on it because there's a whole list of ingredients on the y-axis, which are labeled, right? And the label is ingredient. What's on the bottom, the x-axis? Fat, and it says fat parentheses G. What does that mean? That means the measure is in grams, right? So when it says like 8, that means 8 grams of fat. So what are the 5 ingredients in this sandwich?
Bread, ham, turkey, cheese, mayo.
Yeah, bread, ham, turkey, cheese, and mayo, right? Which ingredient contains the most fat?
Mayonnaise.
How do you know that?
Because it reaches further than all the other.
Yeah, that's the bar that moves the farthest. About how many grams of fat come from mayonnaise? 11. Why 11?
Because it doesn't hit directly on 10, it goes a little
Yeah, it
bit
goes past 10, but it looks like this next line would probably be 12. So it looks like it's right in the middle of 10 and 12. So I would probably agree with you and say 11. Do we know that for sure? Could it also be 10.5?
It could be.
Yeah, it could be somewhere in there. It has to be bigger than 10, and it has to be less than 12. But that's all we know, okay? So I would take any estimate in there. I think the most logical estimate is probably 11, but you're not wrong if you say 10.5, right? Because it could be, okay? All right, how many more grams of fat does ham have than turkey? How would I figure this out?
Taking both of the fats and subtracting them.
Okay, so you want to take both the fats. So how much fat does ham have? 6 grams. And what about the turkey?
3.
It's between 2 and 4, so it's 3. So then how would you tell me how many more grams of fat the ham has? Subtract them and you get 3 grams. So 3 grams more. Okay, how many total fat grams are in this sandwich? How would you do that? You add everything together, right? So bread has how much fat? 1, because it's between 0 and 2. Cheese has how much fat? 9. And then the mayo, we said we'll call it 11. Again, I'm going to call it a whole number, even if it's not exact, because that makes my life easier, right? So if I want a total fat grams, then what do I do? All right, what's 9 plus 11? Plus 6? Plus 3? 29 plus 1 is 30. So Matthew, ultimately, all together, it has how many? 30 what? G. Do I need that G?
Yes.
Yeah, it's just my unit, right? I need to know what I'm talking about. So 30 grams. So why would we need this bar graph? Why would anyone ever need this bar graph? Can you think of some instances in life where you might need this bar graph?
Coach Murray, he likes to eat right.
Yeah, Coach Murray likes to eat right, so he might want to know, right? Okay, he might want to know that this sandwich has a high amount of fat, right? Okay, who else might want to know?
Maybe if you're on a diet.
Okay.
So like instead of eating a full sandwich, now you cut it in half.
Yeah, okay, that's a good idea. So if you're trying to like maybe watch what you eat, you might just look at this ingredient list to keep track of that, right? Also, some people need a lot of fat in their diet. Actually, all of you need a lot of fat in your diet. That's how your brain grows. Okay, your brain grows because of fat. But that's a different tirade I'm going to get on. So don't be afraid of fat. Fat is very good for you. It helps your brain grow. All right? But 30 grams is a lot. So you might look at this and say like, okay, today I'll get it with mayo, but maybe I won't get it with cheese to keep it a little lower fat or something like that. If you want to have a balance like that. How many of you guys have ever been to Subway? Yeah, and on the cups, don't they have something like this? It's like, if you get the turkey, this is the calories, and this is how many grams of fat are in it. Okay, so people who are concerned with what they're eating might want to look at a graph like this. All right? somebody who is trying to advertise for McDonald's might say like, oh, Subway talks about being healthy, but look at how much fat is in a sub sandwich, right? So a Big Mac only has 32, you might as well eat a Big Mac, right? Again, neither here nor there. Sometimes a Big Mac's great, sometimes you're not on a sub sandwich, okay? All right, what percent of the total fat grams in this sandwich are from turkey? So what is this asking?
The percentage.
The percentage? So how do we do that part of
I
it?
know.
Divide what though?
Percent over 100.
Turkey.
Turkey is what? 3, and it's 3 out of how many?
So it's over of percent over 100.
Yeah, so it's is over of, so it is 3 out of 30. So is of equals percent over 100. So I end up doing what? Cross multiplying. So 3 times 100 is 300, and 30. This is like my x, right? So equals 30x, and then what? Divide by 30, divide by 30, and you end up getting x equals 10%. So 10% of that sandwich's fat comes from turkey. Another way you can do it is just what Matthew said, which is 3 divided by 30, which ends up giving you 0.1. That's a decimal. How do you change it to a percent? Move it over twice. So move it once, move it twice, and you end up with 10. So 10, it's still 10%. Either way, those are both fine ways to do that. Okay? So percent is this, you take it as a fraction and convert it to a decimal. And then convert that to a percent. Okay? So when we say interpret, what we're really doing is just answering questions about the data in the graph. So this is a pretty small graph, but it has a lot of stuff in it, right? We answered a lot of questions. Could we answer any more questions? What's another question we could have answered based on this graph?
How much do the grams go down if you take out?
Yeah, how much would the grams go down if you take out the ham? Okay, what's another question you could have answered based on this graph?
How many grams would be in 5 sandwiches?
How many grams would be if I'm really hungry and I have 5 sandwiches? How many grams of fat am I eating, right? Okay.
Every day per week, how much grams will you take in total?
Yeah, good. Like what if you have this sandwich every day for a week, how many grams would you take? Okay, what about if I said how much protein am I getting from this sandwich? Would you be able to answer that?
No.
No, why not? It's out of the scope of this graph, right? This graph is about fat, it's not about protein. So we can't make any assumptions about protein based on this. We could use prior knowledge to maybe say, which of these ingredients, like, are there any ingredients there that have protein? Sure, a lot of those ingredients have protein in them. Cheese has protein in it, turkey and ham have protein in it. But I don't know how much, and I'm not going to guess because this graph doesn't give me that. So interpreting graphs just means taking the information that were displayed visually and turning it into numbers or answers and words that were telling us about this graph. Okay, so that was a bar graph. It was turned on its side. Usually bar graphs are vertical. This one is vertical, but this is a double bar graph. What's the difference between a bar graph and a double bar graph?
That's 2 different. It's
It's
comparing.
comparing 2 different things.
Comparing 2 different things. So it's the same axes for both of them. So both of these, all the information in this graph is about the year 2000, 2001, all the way up to 2005. And it's also all about what?
Sports.
It's all about sports, but what's it measuring? The attendance. So how many people show up at the games, right? But it's not just doing it for football, it's also doing it for basketball. Why? What's the point of a double bar graph? It can compare 2 things. Would this compare 2 things better than if I had 2 separate graphs for each of them?
Yes.
Why? I agree with you. I think it's easier if I look at this as a double bar graph than if I had 1 football and 1 basketball, but what makes it easier?
Because you're right by each other, so you can.
Yeah, you're looking at this and right away I can say which sport has more people go?
Football.
Football. How do you know that? The red bar is higher in every single one of the years, right? So you don't have to figure out, did you have to figure out a single number for that? No, you just look at it and you say, oh, the red bar is taller. Okay, more people go to football games. All right, now you can answer some more nitty-gritty questions, like in which year did State College have the greatest average attendance for basketball? Which year would that be the greatest attendance for basketball? 2003, how do you know that?
It's higher than the rest of them.
It's high. Which one are you comparing it to in that case?
All of the basketball.
All of the basketball. So do I care about the red ones? No, I just care about the yellow-orange color. I'm not sure what color that is. Oh, it's perfect. It's black and white anyway, so it doesn't matter. but whatever the other color is, right? My second one. Okay, so basketball was the highest in 2003, but what if I ask something like, on average, how many more people attended a football game than a basketball game in 2001?
Add them all.
No, you'll see like where the number stops after basketball. Where the
Okay,
number stops after
so
football.
I'm just looking at 2001. Matthew, if I were looking at from 2000 to 2005, what would you have to do?
Oh, add them.
Then you'd have to add them all up. We don't even have to do that much work, right? Because we're just looking at 1 year. So we're looking at 2001. What's the average number of people who attended a football game in 2001?
24.
In 2001?
Oh, 20.
20,000. It's not just 20 people, it's 20,000, right? Does that matter?
Yes.
Yes? How do you know it's 20,000? Where'd that come from?
I did my pretty.
Because right here it tells you what, Montreal?
How many people?
It says thousands, right? And so that means all those numbers actually stand for not just 5, but 5,000, not just 10, but 10,000. Okay, what about basketball?
12, 13,
So it's above 10, right? And it's not at 15, so it's somewhere between 10 and 15. Can you get an exact number? No? What do we want to pick?
12.
Maybe 12? Okay, so I'm going to say 12,000 works. Pretty much anything in there that isn't 15,000 exactly or 10,000 exactly, it's got to be a little bit above it. All right, does that mean there's a little margin for error? What does it mean when I say margin for error?
Room for mistakes.
Room for mistakes, okay? And I understand that. On a test or a quiz, I understand that. When you're interpreting a graph, there's places where you're allowed to make mistakes. That's one of them. But if you told me there were 8,000 people at basketball, is that within the margin of error? No. Why is that one not within the margin of
It's
error?
like too far off.
It's too far off. It's way off, right? It's below, that would be below that line. Okay, so then the question says how many more people attended a football game, so then what do? You would say 8,000. Where's 8,000 coming from?
Subtracting the two.
Yep, subtract them. So about 8,000 more go to football than basketball. Okay? So there's a lot of data in that graph also. What's another question you could ask and answer? What's another question you could ask and answer?
Between the year 2000 and 2002, how many more people attended football games than basketball?
Okay, so putting like aggregating data, right? Between the year 2000 and 2002, how many more people went to football? Okay, what would you say is the biggest year for football at State College? Why 2002? Yeah, it's the tallest, right? It's the tallest of those red. And it looks like basketball stays a little bit more steady. But football, what happens? Spiked, and then what happened? Yeah, people kind of stopped going. It gets a little bit closer to basketball after 2002. Okay? So then if I asked you to interpret that and tell me what do you think happened, what could you tell me?
A scandal.
A scandal, yeah. Maybe a scandal happened in 2002, right? Yeah. No, I think that's true because that happens all the time in sports, right?
They cheated for that.
So yeah, they should like SMU got they got and we're like somebody what happened I'm gonna embarrass myself now, but like somebody got their Heisman revoked, right? And so like all of a sudden there was cheating and now people don't want to go to the games. Good.
Correlate from the year 2000 to 2002, the quarterback, he was like really popular.
Oh, okay. Yeah, good.
Then he went to the NFL. And just,
Yeah. So he left in his junior year, right? And so then people were like, I'm not going anymore. He was the only good one on the team. Good. Okay. All right. What would you say about basketball? Was there no scandal? They're just steady?
Just not as popular.
Not as popular, but consistent, right?
If it was
People
a
are
small-
consistently fans.
If
Good.
it was a small campus, if more people went to the football games, they're automatically going to let that many people over the basketball games.
Okay, yeah, that's a good point. Yeah, good. Okay, so my point here is that this is a small graph, right? But there's a lot of stuff in it. You can answer a lot of stuff about something based on a graph. Okay, what's this called?
Line
A
graph.
line graph? What's the difference?
It's a line.
It's a line. Yes, it is a line compared to bars. Why does that, what's the difference between the data you put in a bar graph and the data you put in a
You can like
line
go
graph?
down or like up.
Line graph shows over time.
Line graph shows a relationship over time, right? It really measures a relationship over time because it shows a connection. So whereas in our previous graph, right, Did the fat and ham have anything to do with the fat and the cheese? No, those were two separate bars. They had nothing to do with each other. Just because cheese has a lot of fat doesn't mean ham has a lot of fat, right? But in a line graph assumes that there's some relationship between the two pieces of data. So what's this graph measuring?
Temperature.
Temperature over the course of what?
Monday.
Over the course of time on Monday, right? And our temperature is measured in Fahrenheit degrees. Okay, so Fahrenheit. What time was the temperature the warmest? 4 p.m. All right, during what 4-hour time period did the temperature increase the most? So what are we looking for there? You're looking for the biggest increase, so you're looking for where the line does what? Goes up the most. So the first thing you can throw out is, when does the line not go up?
4 p.m. to
4 p.m. to 8 p.m., it doesn't go up at all. So we can throw out that interval. Is it going up from noon to 4?
Barely.
Barely. So we can probably get rid of that too. So really, which ones are you debating between?
Midnight to 4 a.m.
Midnight to 4,
And 4 to 8 a.m.
4 to 8,
And 8 to noon.
and 8 to noon. So how do you then figure this out? You could figure out the actual temperatures, and you can also look at the slope of the line. So you're looking for the line that has the what slope? The biggest slope, the steepest slope, right? Which one of these three, let's call this 1, 2, and 3, which one appears to be the steepest?
8 a.m. to noon.
Which one?
8 a.m. to noon.
Yeah, 8 a.m. to noon, so number 3, right? This one appears to be the steepest. It looks like it's going from about how many degrees? What's between 60 and 80? 70, so it looks like it's going about from 70 up to what? 80, so how much of an increase is that? 10 degrees. From here, what's it at here?
60.
Is it right at 60?
No.
It's a little bit above there, maybe 62. So is that bigger or smaller?
Small.
Smaller increase. So what's our biggest increase then?
3.
Yep, interval 3. So the answer to that question would be from 8 a.m. to noon. Right? Can you sit up, please? Thank you. Sit up, please. Thank you. Okay. What do we have here? It is a double line graph. So it's got two pieces of data from what? What are those two lines?
Airline.
Airlines. So there's airline A and airline B. On the graph, airline A is blue or blue-green, and on the graph, airline B is purple. In what months did airline B charge more than airline A?
J, A.
So you're looking for where airline B charged more. So that means where the purple is what? Above or below?
Above.
Above. So
A,
where is the
S.
purple line above?
S.
A and S. And anywhere else? So what are those? What's AS?
April and
April and September. Good. They stand for months, right? So that would be month April and September. All right. During which months did the airlines charge the same airfare?
Ooh. M.
A.
M.
April. Oh yeah.
A. M.
Are these exactly the same?
May.
No. So I would say that's not the same. All right.
I would say it's May.
I would say May is definitely the same. They're exactly on the same spot. I would actually not say October because it might be a little hard to see, but purple is actually a little bit lower than blue. Okay? So May is the only month where they charge the same amount. If you had to use this to decide, which one would you probably want to book with?
The blue May.
You would want to book with the blue. Really? Why?
What's the question?
Which airline do you probably want to book with?
Oh, airline.
Probably airline B. Why?
Cheaper.
Yeah, and overall it looks like it's cheaper. And even when it's not cheaper, how far away are they? There. Like in April, it's pretty small, right? Whereas airline A, what does it look like here?
Pretty big.
Yeah, it's a pretty big increase. Okay? All right. What?
Oh, I said supply.
Supply and demand. That's true. Okay, what is this kind of graph?
Circle graph.
It's a circle graph, and every circle graph really stands for what?
Percentages.
Percent out of 100.
Percentages out of 100. Yeah, very good. So percents out of 100. So every circle graph, or pie chart sometimes we call them, is a percent out of 100. Which two fruits together make up half of this fruit salad?
Banana and strawberry.
Banana and strawberry. Okay, banana and strawberry. Why isn't it like cantaloupe, kiwi, and blueberry?
Because cantaloupe is actually more than.
Cantaloupe is more than a quarter. Good.
You gotta see whichever adds up to 50.
I need the one where two of them add up to 50, right? Do these three add up to 50?
No. Yes.
Yes, but it
Yeah, but it's then there's three and it says which two. Good. So it would have to be strawberry, banana. All right. Which fruit is used more than any other?
Cantaloupe.
How do you know?
Oh,
It takes up more
takes
than-
up more.
Yeah, it takes up the most space. How can we find what percent of the fruit salad is cantaloupe?
percent of 100.
Percent is over of, you go percent out of 100. So the first thing you'd have to do is figure out how many total cups of fruit salad there are. So how many strawberry and banana are there? Four. And if that's half, then the whole thing must be eight. So it'd be 8 cups altogether. And cantaloupe is how much of that? 2.5. Why am I going to make it 2.5 instead of 2.5? Because it's easier. All right, equals percent out of 100. What do I do now? Cross multiply, which gives me 250 equals 8x. How do I finish?
31%.
Is what?
I think 31%.
All right.
Yeah, 31.25.
31.25%. So cantaloupe is 31.25% of the fruit salad. Can you change this proportion to figure out any of the fruits?
Yes.
Which number would change?
The top
2.5.
The 2.5, would anything else change?
No.
No, it would always still be out of 8. And where did the 8 come from again?
The total.
Total. So adding it all together, and then the 100 is,
Percent or out.
percent is always out of 100. Okay, so it has to be out of 100. Good. All right, so, yes.
You didn't ask what other questions could we use?
Oh, okay, what other questions could we answer based on this? Oh,
I was hoping somebody else.
does anybody else, can anyone think of any other questions you could ask based on this graph?
The same thing as number 3, except just change from.
Yeah, change the fruit. Okay, what fruit do people not like?
Kiwi.
Kiwi. Why?
It's sour with
The
this.
person, not why don't people
Oh.
like kiwi. How do you know that kiwi is like the least in demand?
Smart.
Why do we know that kiwi is the
Oh,
least?
because it has
Has the smallest? Does that necessarily mean that people don't like it?
Yeah,
or just
actually,
that
I
you
actually like
need
kiwi.
less of it
Yeah.
to have an impact, right? Maybe people like it more, but absence makes the heart grow fonder.
And this is for a fruit salad.
It's a fruit salad recipe, yeah. So maybe also kiwis are really what?
Sour.
Sour, yes, but compared to a cantaloupe,
Oh, they're small.
still sour, but they're way smaller, right? So if you buy one cantaloupe, it's gonna make a lot. Whereas if you buy, like, you'd have to buy, how many kiwis would you have to buy to make 12.5 cups? You need a lot of kiwis. And they're a pain because you gotta, like, cut the fur off. And so you might wanna keep that in mind. You can't necessarily say, like, oh, people hate kiwis, but there is probably a reason that the number is smaller. Okay, go do these at your boards. All right, so to wrap up then, how can you decide which graph to use? Bar graph, line graph, double bar, double line, or pie chart? How can you decide? So for instance, this question has a table that says livestock show entries, and it has an animal, a list of animals, and then a number of animals. So which one might you use here? A bar graph, a line graph, or a pie chart?
Pie chart.
Okay, some people say pie chart, some people say bar graph. Why not line?
It's not a time.
It's not a time, there's not a relationship between it, right? Just because you bring 38 chickens doesn't mean you also have to bring 32 horses, right? There's no relationship between the two pieces of data. Diego, you said pie chart. How come pie chart?
Because it's like showing how many more entries.
Okay, so you can give me, it would be like the percent of the entries that are chickens. Good. I would say either one would work. I'd probably do a bar graph here, but either one, pie chart or bar graph, would work there. All right, what about this one? Division of crops. Crops, corn, fallow, mixed vegetables, soybeans, wheat, and then acres. Which type of display here? I would think pie here. Why pie?
It's like
Again, kind of the same thing, right? Could be pie, could be graph. Why would we maybe want a pie chart here? Yeah, it's split up into, like, you might think about this as if it's like somebody's farm, and they might want to know, like, what percentage of your farm is devoted to mixed vegetables or whatever. Could it be also done in a bar graph? Absolutely. Again, why not a line graph?
It's not.
There's not measuring any type of relationship between those two things or time. Okay, so on your exit ticket, you probably will not have time to finish this. You only have about 2 minutes, but get done what you can. You're going to do all 4, and if you do not finish it, show it to me tomorrow.